All right, I think we'll go ahead and get started. Good afternoon, and thank you all for joining us for our webinar today. Our session today is being led by our technical director and one of the managing partners here at CAD Microsolutions, Jairo Castellanos. This marks the first session in a digital series we're going to be running throughout 2020, taking a closer look at the powerful business experience platform from Dassault Systems, the 3D Experience platform. During this session, we're going to be taking a look at the simulation capabilities offered on the platform in SIMULIAworks, powered by industry-leading Abaqus technology. As usual, we'll save some time at the end of the session for a question and answer period, so feel free to type those questions into the GoToWebinar panel at any time. Before I pass things over to Jairo to kick us off, there are a couple of quick announcements to share. First, as you may or may not have heard by now, CAD Micro is growing. We've recently opened up new offices in New Westminster, British Columbia, in Calgary, Alberta, and have a growing team in Western Canada to be closer to our clients out west. If you have any questions or would like to be put in touch with our local team members, feel free to reach out and we'll connect you. Secondly, there are some excellent promotions available for both the SOLIDWORKS desktop product line and the 3D Experience platform that were just announced this week. For the desktop line, there's a free upgrade promotion available. Purchase nearly any license of SOLIDWORKS and be upgraded to the next level of that product for free. For those looking to get started on the 3D Experience platform, with the purchase of a 1-year license of Collaborative Designer for SOLIDWORKS, we're offering 2 complimentary 3-month Collaborative Business Innovator licenses to enable real-time collaboration on the cloud with your team. We'll include some more information on these when we email you the recording of today's session, but you can certainly reach out to us for more information in the meantime. Okay, without further ado, I think I will pass things over to Jairo to get us started today.
Thank you so much, Jessica. Welcome, everyone. The first comment that I have about this is I don't think we have enough of a gap here for social distancing. We're going to have to change our PowerPoint. With that said, let's talk about advanced simulation with SIMULIAworks. This is, like Jessica said, is the first webinar that we're going to be doing of a series of webinars of the technology that is in the 3D Experience platform. And we're going to start with the simulation side of the product. In this webinar, I'm going to be covering several different things. The first one is that I want to cover about cover simulation, the different simulation types that we have access to. Then we're going to be talking about what is SIMULIAworks, and then what are the tools that make that platform advance, and why we can make or do these type of simulations better than with some of the products that we may be already familiar with. So if we're starting about simulation, simulation is a very broad term that means different things to different people. There are different types of simulations, different simulation kind of domains. We have fluid dynamics. When we want to have access to our fluid flow, we need to know pressures, velocity of the fluid, thermal effects. We have as well injection molding. In this case, instead of analyzing the product, we're analyzing the manufacturing process. In this injection molding, we are able to analyze the fill stage, packing, warping, and the mold cooling side of things. For some other people, simulation may mean kinematics and dynamics of rigid bodies. So when you're looking at adding some kind of motors, you have products that have a lot of movement, and you need to analyze that. Kinematics will take a look at the velocity, acceleration, displacement of those rigid bodies, and then dynamics will add to that forces and pressures based on those that movement. And then we also have kind of the structural. The structural is when we're looking at the stresses, the strains, deflections, the fatigue, drop test, all of these type of analysis, we put them under kind of the structural vertical. And then on top of that, a simulation may mean more for other people. So for example, electromagnetic simulation, when we need to know like a magnetic field, an energy field, based on a current. We can do that. For some other people, robotic simulation is what they need to get out of the solution tools that they have. Discrete event simulation and factory simulation as well. We have CNC and tool path and optimization of those type of things that may be considered by some other people as simulation as well. We have virtual reality and augmented reality. Again, as well, some people will consider that as simulation. And then there is a lot of other products. We within CAD Micro, within the partnerships that we have solutions for all of these products. And these solutions, some of them or a lot of them are within the 3D Experience platform. There are also solutions in our installed SOLIDWORKS platform, and as well as some other partner products that we partner with. But today we're going to be talking about the structural. Structural is probably the what people think about when people talk about simulation or think about simulation. The structural domain, the structural vertical, is probably the first thing that comes to mind. We're going to be talking about the structural because it's not only the most common one that people would do. Is sometimes is the first type of simulation that people get into, but also is because a lot of the things that we're going to cover in here, a lot of the things that I'm going to be talking about related to the structural simulation, like meshing, like collaboration within SOLIDWORKS and the 3D Experience platform, they would apply to these other domains. So for today, I'm going to be concentrating on structural. I'm talking about things that we cannot do within that domain, it's just within the structural domain, but chances are we can do it within the different domains that we have. So that is the simulation. So the simulation that we're going to be talking about is structural. And now we're going to look at what the SIMULIAworks is and how is that going to help me within that structural vertical. So SIMULIAworks is a brand, and it's a brand that contains a portfolio of simulation products. There are several characteristics of these products that are common throughout them. The three that I want to highlight today are that it is a SOLIDWORKS connected product. It doesn't require for you to have SOLIDWORKS, but based on the poll that we did when people were subscribing to this webinar, based on our customer base and the people that are joining today, most of you do have SOLIDWORKS. So I'm going to concentrate today to talk about SOLIDWORKS, not because it's the only workflow that we have, but it's the one that I am more familiar with, but also our audience is more familiar with. So this SOLIDWORKS connection is very important. There are other connections, like I said, you could have a connection with CATIA, a connection with Autodesk Inventor. You don't even have to have a CAD system to be able to use these. You could have a modeling system within the platform as well. But again, today we're going to highlight the kind of the SOLIDWORKS connected portion of it. We're also going to be talking about the collaboration within the 3D experience. Once we have this geometry in the 3D experience, then there is a big room of possibilities that we can leverage in that 3D experience platform. There is data management, there is a PLM, bill of materials, there is collaboration tools, there is a whole platform. The 3D experience is a whole platform that will give us the different tools that can help with the process that we're working on. And then the third characteristics that I want to highlight about the SIMULIAworks portfolio of products is the power that it has. It's such a powerful tool. It is powered by the Abaqus solvers, which are very well recognized in the structural simulation. And when I'm talking about powered by Abaqus, I'm talking about the structural side of the SIMULIAworks brand. And these will brings a lot of technology that is proven and that is recognized in the industry. The the first few things that I'm going to be talking about, the first three items, the portfolio of products, the SOLIDWORKS connection, and the collaboration, I'm going to do a brief overview of them. We could have, and we will have, webinars in each of those subjects, but today I want to spend a little more time in the technical aspect of the FEA process, a little bit more in detail. So I'm going to mention the top three, but we're going to spend a little bit more time on the kind of powerful aspect of the platform. So the first thing is it is a portfolio of products. There are different roles of these products within this brand that cater for different type of users. We have from a collaborator that doesn't really need to create simulation, is more a consumer of that simulation, all the way to an analyst that would be able to do very high-end simulations. Sorry. These portfolio of products, there are different roles that we will be able to access. I'm not going to go through the detail of what is what type of features you have in each of the roles. I just want to highlight that we have a whole range of products that people can use and companies can use. These products, you may want to have the kind of higher end functionality. You can have kind of the basic functionality, and these products could also be a complement to simulation tools that you already have, like SOLIDWORKS simulation. In terms of the SOLIDWORKS connection of it, so the workflow that we're going to be talking about today is a workflow where we start with a SOLIDWORKS assembly. We have an assembly in SOLIDWORKS. We work in SOLIDWORKS for our CAD environment, for our modeling environment. We have something in there. How do I make this simulation in the platform? So we're going to start with a SOLIDWORKS assembly. We're going to pass that onto the platform through what we call the PLM services. And then once we have it in the platform, we're going to do simulation on it. We're going to run the simulation, and then you could change the geometry and in SOLIDWORKS and recalculate that simulation. This is, again, one of the workflows. You don't have to start with SOLIDWORKS. You could start with another CAD modeling package. You could start with just geometry, SOLIDWORKS files that you could import directly to the platform, or just generic files like a step file or an IGES file. But let's start with the workflow where I have in SOLIDWORKS. So let me show you that actually in the interface. So I have SOLIDWORKS right here. I'm going to open an assembly. And let's say that the assembly that I'm going to open is this one. And in this case, this is just a basic assembly, a couple of parts. You see here, this right now is in my desktop, in my local drive, and I want to move to this to the platform. So what I'm going to do here is that I have an add-in that is called a PLM services add-in. And when I do that, similar to kind of what we have in PDM, that it would recognize that these files that I have, they're not added to PDM. They're not in my local view. This is what this warning is telling me. These files are not in my local view of the PLM services. So when I click on this and I go to save, the first thing that it's going to do for me is that it's going to create this type of work. And then you can see here that it already kind of finds some of the files. I'm still going to go ahead and copy this into the platform. Let me just kind of skip that and then add that to the platform. I had done this before, so let me just kind of open this one. There you go. Once we have it in here, then you'll see that it'll recognize that I'm on it'll recognize that I'm on that platform, and then I have similar functionality as PDN, or it is a PDN package. So I could, if I want to work on this, I'm going to right click on that. I can reserve this. Once I reserve this, I'm going to be able to do kind of work on it. I have kind of write access to it, and have general PDM functionality in here. Now, within this tool, I can also link to some of those collaboration opportunities that we have within the 3D experience. So for example, in here, if I wanna look at my kind of change management, let's say that this was it, there were a series of issues that were tracked. This can be done in the platform, and then a change work was issued, like an engineering change order was issued. I can take a look at those here. And to do that, I can look at my roles. So if I click on my roles, I'm gonna open an app that is called a change action. And if I click on that action, on that change action, you'll see that it's kind of loading the different work that we have in those change actions. So here is highlighting that this object is not attached to a change right now, and it's not. But it says that I have two change orders open for me. So what I can do is I can use one of these change orders and track the changes that I'm making to this geometry in those change orders. To do that, I could do it kind of from here, but also if I didn't want to search on it, I can do it right here. I can go to my change actions. It will load the different current change orders that I have assigned, and then I can select that I want to work with, and then click OK. And then you see here that this icon is now turned yellow, and it's telling me that every work that I'm doing here, the work that is related to this geometry, is now attached to that issue. There is a lot more functionality in terms of what we can do within the SOLIDWORKS collaborator. And this is going to be a subject of a different webinar. I just wanted to highlight and I kind of give a brief overview of what we have, and just kind of pique your interest so you can so you watch the next webinar on this. Once we have all of this kind of checked in our platform, then I can open that up in my native app or in the browser. So let me go back to my PowerPoint in here. So we've done this, and now we're gonna go into the collaboration portion of it. So you saw a little bit of that collaboration inside the SOLIDWORKS platform, and inside of the SOLIDWORKS interface. But we can also obviously do that in our web browser. So right here, I'm on a web browser. I'm connected or logged on into the platform, and the way that I'm organizing my information is based on what we call a dashboard. So I created a dashboard that contains the information that is relevant to me. And in here I have some bookmarks. That is a way of organizing the information and the content that you have. I also have a project planning app. I have, for example, a project that I created to kind of plan this webinar. I have some tasks that I need to do, some that are in progress, some that are done, and there is kind of a project planning functionality within the platform. Then I also have a 3D space that is kind of a set of files or all kind of all my information is in here. I call it, think of it as a drive that we have. And I have access to all of that information in there. And then I have in here as well kind of my issue management. So I have an issue that is looking that is tracked against a geometry and against a product, right? So there is issue management and issue tracking. And in this case, the scenario that we're going to be working on, there is an issue that I have created that is referring to a product that is that buckle assembly that we're going to analyze. Again, similar to what we said before about the SOLIDWORKS connector, there is going to be a different webinar where we're going to explore this collaboration in the 3D experience a lot more. So now let's talk about kind of the FEA portion of it, the simulation portion of it. So we had that geometry, we exported or we added that geometry into the platform. Within the platform, there is a lot of things that we can do, but one of them is obviously use the analysis tools in the platform to do this simulation. So the way that I'm going to be presenting some of the highlights of that simulation capabilities is by going through what I talk about that are the 6 steps of the design analysis. Every time that I'm doing kind of my simulation training or in my mind when I'm doing a simulation, I always go through these kind of 6 steps of design analysis: the geometry, the material, discretizing the model, meshing the model. Then we have to do our boundary conditions, our interactions, our kind of contacts. Then we solve them, and then we do interpretation of the results. So we're gonna go through those 6 steps, and in each of those 6 steps, I'll show you how that looks in the platform, in kind of in that buckle assembly that we're looking at, but also I'll highlight some of these kind of added functionality that makes these such appealing solutions, such an exciting solution because of the depth of functionality. So let's start with the geometry. So when you're doing a simulation, you need to create, or in many cases, you need to make modifications on that geometry for the purpose of that simulation. There is kind of simplifications that needs to happen and so forth. So to do that, we have an environment that is a dedicated environment to do these type of modifications. So let me, and I'm gonna try this, hopefully this works. I'm gonna use kind of a whiteboard in here to walk you through those steps. So the first thing that we have is that we have our SOLIDWORKS geometry, our CAD geometry. So if we talk about that, let's say that we have our SOLIDWORKS geometry, and within the SOLIDWORKS, we're talking about our CAD model. This CAD model that we have is, in my case, I'm using SOLIDWORKS. It is a bunch of files. It's a file-based system. So we have that. Now, what I just did at the beginning of this presentation is that I uploaded that to the platform. To upload that to the platform, in that process, we end up with what is called a physical product. So that information that is stored in my files, kind of in my local folder or in PDM or wherever it is, that information that is in the file format, it becomes what we call a physical product. And this physical product, it is not a file, is a kind of an object-based system. And this object-based system is essentially just a record in a database that makes it very flexible and very useful later on. But it is a 3D representation, a fully functional 3D representation on that. Now, I have that physical product. I can use that just to view, to annotate, to have kind of my digital digital twin and do kind of MBD type of functionality. There is a whole set of tools that I have in there. But for the example of today, we're gonna grab that physical product and we're gonna create a simulation. So when we create a simulation, then now we have our simulation model. And this simulation model is a different entity within our database, within our records. And then in this simulation model, this is where we're gonna set up the simulation, run and create different scenarios, and measure and everything else. Now, in this simulation model, I also have the ability of making these geometry changes. So if I have a simulation model in here, within our native app, we can do kind of these geometry changes, right? That are for the purpose of the simulation. And this is important because now I'm making these changes in a tool that is dedicated to make changes for simulation. So it has kind of simplification, idealization, it has kind of planes and boundary conditions, geometry that is already there. So it makes it easier for me, but it's also making those changes into this simulation model that is a different entity. Just to compare this process to kind of the typical process that we use within PDM and SOLIDWORKS model, for me to do that simulation, typically either I have to do then the simulation on kind of the CAD files, or I would have to create a copy of the CAD files to make that simulation. If I want to alter that geometry, then I'm using kind of CAD modeling tools to do that are very good within SOLIDWORKS, but maybe they're not optimized to make geometry changes for the purpose of a FEA study. And also, I need to have kind of ownership right. If I'm working in a PDM environment, if I'm making this setting up a simulation, then I'm working on that file. So I have to have ownership of that file, and then nobody else can be working on it. And I may potentially be modifying or adding all of these geometry changes to a file that is not intended to do that. It's intended for kind of manufacturing purposes. So either I do that by kind of using configurations or by creating a copy of that CAD file for the purpose of simulation, but now I have two set of files that I need to track. So it becomes kind of very cumbersome process. So in here, I can do that. I don't need to have access to the CAD files. I don't need to have access to the physical product either. I'm doing that in the simulation model environment. Let's say that we work through that geometry and we're happy with that, then we will be able to set up a simulation. And one of the things that we go through that simulation that I'll kind of explain in more detail later on is obviously meshing that model. And when I do that, I can create this, what we call an FEM, right? A final element model that essentially is a mesh model of that geometry that I have. And I could have different mesh models of the same simulation model that I have, right? So I want to try this simulation using solid elements or this type of solid elements as opposed to this other type of solid element. We can do that in this mesh environment. Once I'm happy with this mesh environment, the mesh, I can also create kind of my scenario. So during that or in that simulation model, I could also attach the scenarios, right? Which is the actual simulation. And then similar to kind of any other simulation tool, you could have different scenarios. You're analyzing kind of on the same geometry, on the same edge, kind of different load conditions, different connections, and so forth, right? So all of these are different entities, even though they're kind of separated by different entities, because it's not a file-based system but an object-based system, is very easily for me to mix and match. So I can create, for example, if I have a scenario that is that is looking at this FEA model, I can reattach these to another model, right? A second interpretation of that simulation model. But it is a fully parametric setup. So if I make changes to my CAD geometry, I can say, okay, update all of these physical product simulation models, mesh, and then run the scenario based on the changes of that CAD geometry. So let me show you that in the interface. So in the interface, you can see here on the right, this is how you would see that, right? And this is kind of the design tree on that app. And you can see that we have like the geometry, but then we have this idealized geometry. So there is the geometry, like this is, I think of it, the physical model or physical product, then this idealized geometry. And then from that geometry, then we have the mesh, and then on the mesh, we have kind of the material properties, and then the different simulation scenarios will be underneath. Let me show you that in the actual kind of interface. So this is what we call the native interface. Essentially, it looks like a very empty browser or a clear browser. I have kind of different tabs in here, and one of the tabs that I have is the tab where I'm running that simulation, or where I have run that simulation. And you can see, again, similar to what I described before, I have kind of my physical model in there. Within that physical model, I didn't make any changes on the geometry here. It was simple enough that I used the geometry as it came from SOLIDWORKS. So I don't have kind of an extra step of idealizing that geometry, but I do have kind of the finite element model. And then I have kind of the material that is attached to it. And then I have the scenario that I've done, which is the actual simulation, and then the result for each of the scenarios created. So that is the tool. That's how it looks. Now, if I'm looking at this simulation, I have kind of a view of that kind of relationship in here as well. So if I go to kind of my new tab and I look for that part, right? So that assembly that is kind of my buckle in here, then you see that kind of it searches the system for it. It gives me access to kind of all the different things that have buckle in their name. And you can see that I have different types or different tags that I can add, and then filter those search results based on that. So I can see very quickly in here that I have that simulation. And then if I click on this, I'm going to show you kind of this related object view of what I'm talking about, right? So that is, I found the simulation. I opened that simulation in the related object view, and then you can see here, oh, I have a simulation. This simulation is simulating this kind of physical product, right? That simulation is using this kind of finite element model, right? I'm tagging this on this bookmark that I had in my platform. If I click, for example, in here, then you see that I can expand the relationships farther on. And oh, if that physical model that I had is looking at a specific material, it is also in the same bookmark that I'm using, and is also attached to an issue. And this is the issue that I was talking about. So you can see very graphically, you can go through the relationships of all of these different objects and kind of work with them. So that is kind of step number one, dealing with the geometry, looking at what we can do in that geometry, and then kind of storing that geometry in the platform. Step number 2 would be assigning the material. And when we're talking about the material, then we're talking about two different things. We're talking about material properties, and we're talking about material models. So there are different types of material models that we have access to. And just to give you an idea, in SOLIDWORKS Simulation Premium, we have the ability to have different material models. One of them would be the linear elastic material models. Under that linear elastic, we have two options: linear elastic, orthotropic, or isotropic. In the platform, based on the SIMULIAworks product, only within the linear elastic we would have 6 different implementations of that, and it will let me create different type of definition for that linear elastic. So for example, the isotropic is when we have all the behavior is the same in all directions. Orthotropic is when the behavior is different in the different of the X, Y, and Z directions. Engineering constant is another way of defining an orthotropic material. Lamina would be a way of a material model where we have a plane where it's isotropic, but then a different material proper or material behavior perpendicular to that. And isotropic is when it is linear, has different behavior in different directions, but it doesn't necessarily have to be in the X, Y, and Z, and so forth. So different ways of implementing this. So the linear elastic, we also have kind of large strain elasticity material models that we would have in there. And again, this is just kind of one set of implementations of the different material models. So for these hyperelastic materials, again, if we were to compare these to our SOLIDWORKS Simulation Premium, we have kind of the Mooney-Rivlin in there. We have the Ogden, and that's basically it. What we have for hyperelastic materials. In here, we have a lot more functionality, a lot more material models that we can have. So these material models, right, just the linear elastic and the hyperelastic material are just two of the different material models that we kind of have access to. I'm not going to go through all of them, but we do have in one central database that ability to define the different set of material models for the different domains of simulation, which makes it very practical. In the same database, I have kind of the materials and the material models for my structural side of things, but also for my injection molding, also for my fluid. And that being in the same platform helps me if I ever want to do a couple set of analysis. And it helps me manage those materials as well in here. In terms of the structural, then we have kind of elastic, plastic, hyperelastic, and user-defined material models on top of, I guess you could look at thermal material models as well with the structural side of things. Those are the main, and all of these can be either linear or non-linear. And then they can be also temperature-based properties. So let's take a look at that in the interface. So if I go, for example, to, let me just close this relationship explorer in here. I'm going to go to my material editor, and let me show you how that looks in the interface. If I wanted to create a material, I would give it kind of a new name, new material here. And we have kind of the core material, which is kind of the full solid material, but also covering materials in here. And then under my domains, then I can select my simulation domain. I could also, it's the same database that I could use for like rendering, like appearance materials. And this is kind of what we call the appearance domain, or the drafting domain. So kind of hatching and all of that in a 2D drawing. But in this case, we're just kind of thinking in simulation terms. So if I click on that, then you see that it would kind of create these materials, and then we can kind of look at the material properties of these simulation. And then we could define that material based on the kind of the different values that we have. In the simulation that we created, if we go kind of back to that, then you can see here that I have a material that was created and that I was used in the simulation, and then in that material, then we can have the kind of look at the properties of that material as well. And then you can see that I have kind of the domain. Everything that I have in the 3D Experience platform, then you have is able to be kept track, similar to what we do with files in a PBM system, which is we can have workflows, we can have approval processes, we can have a life cycle attached to any entity, including the material. So if we have only a set of approved materials, a set of approval material properties that we want to keep, then all of these can be controlled and tracked, which is an excellent benefit for an ISO or any other quality system in here. So material properties and material capabilities. The next thing that we would do in our kind of simulation is meshing. So there are different type of or a dedicated mesh tool that we have within our analysis or within the SIMULIAworks platform, and we have a different approach. And I'm comparing these to our SolidWorks simulation. When we mesh something in SolidWorks simulation, we're meshing the assembly, and that is kind of one methodology, which is within that assembly, we look at what we have in there and we mesh that, but that mesh lives in the environment of that assembly and in the environment of that simulation. And here, we can have, as you saw at the beginning, we can have different mesh elements. And these mesh elements, I can create them at the part level, I can create them at the subassembly level, I can create them at the main assembly level, and they can be reused. So these final element models that I was talking about before, then it becomes almost like a block that I can enter into higher end or bigger range simulations. So it's a different approach that if you're using SolidWorks simulation, we don't have right now, but it makes it more flexible. You can customize, you can target, you can create a simulation and fine tune the mesh for that object in that simulation, and then reuse that in higher like in main assemblies and sub-assemblies as well. We also have, right, so not only the approach to meshing is different, but also the type of elements that we have is different. So again, and I'm comparing these to our SolidWorks simulation product because that's the one that I'm most familiar with, but you can compare these to any other simulation tool that you have, right? That typically you would have like a 1D, 2D, and 3D elements. And in the SolidWorks portfolio, we have 2Ds are kind of triangular, and 3Ds are tetrahedron, or TET elements. In here, we have access, obviously, to those, but also to other type of elements. So we have the swept 3D and we have the hex and different algorithms or different ways of using those type of elements. Just to give you an idea on what the difference is, the hex or the brick elements are a very powerful type of element. The implementation is more robust. It can run faster, and if I wanted to mesh using tetrahedral elements within that has mesh, I need kind of a 4-to-1 ratio of the amount of elements using with kind of the same characteristics for one hex element. So four tetrahedron for hex for one hex, and that makes it faster to solve. So not only is kind of more powerful, but it also is faster to run. So the ability to have different type of meshes and the mesh elements makes the software more powerful. And the same would apply to 2D element surface meshes and 1D elements. We also have tools that helps us create and analyze the mesh itself. And then we have tools that help us kind of visualize that mesh. In here, this is kind of the mesh that we have. You can see that we have the finite element mesh in there. I can change to kind of that mesh environment, and then it would show me the mesh. The way that this was done, I'm using tetrahedral elements in here, and I did like a mesh control, you can see in this area. So different type of elements and meshes that you can create within the platform. As I am clicking on these icons, you see that kind of my toolbar changes, but also my environment changes. If you see in the top here, I'm in my mesh creation environment. So these are what we call different apps. It's within the same interface. So it's not that I'm closing this and opening a different program. The different apps within the roles in SIMULIAworks is just different environments that we have access to within the same kind of interface or platform. So this one, and when I'm in that environment, in this case, mesh creation, all the tools, all the menus, everything that I do here, it is specific to that environment, mesh creation in this case. And then if I go, for example, to kind of my scenario one, then you see that then now this is going to be changing to the scenario, and then I can change or get that as well in here, right? Mechanical scenario creation. So different tools as well as the kind of the result one in here. So let's continue. So that is the meshing. Then we also have connections. There is a set of connections in here similar to what we have in our simulation, in SOLIDWORKS simulation, bolt connectors, pin connectors, all of these type of things are available here. They're more powerful in the platform. You're able to use these type of tools in nonlinear dynamics and all type of simulation types as well. But one of the main differentiators of what we can do in here compared to other tools is the contacts, the global contacts. To be able to do a simulation like this, it would be very difficult to do that, or you wouldn't necessarily be able to do that in SOLIDWORKS Simulation Premium. The amount of contacts that you would have in here, it would be very difficult to set because the way that we are setting those contacts in an efficient manner in SOLIDWORKS simulation is that we will need to create this simulation, these contact pairs. We have a global contact, but there is a penalty that it gets created in terms of computational effort when we use it. That's not the case in here. There is a very, very efficient global contact or general contact in here that it actually lets you use that and run in your simulation, which is what I've done in here. In terms of these kind of interactions or these contacts, I added those interactions, that general contact, and the general contact that I have is looking at these properties in here. So if I kind of edit that, then you see that I'm doing a global no penetration, normal kind of behavior hard contact in there. And then I'm reusing that in the general contact. So I can set different contact properties and then you reuse that in the general contact or in contact pairs. In terms, actually, let's go back to here. In terms of the kind of that step of boundary conditions, in here I'm also doing kind of adding some restraints, very kind of typical restraint. I'm restraining kind of at the bottom here, and then I'm adding a load. My load is just a prescribed displacement at the top. I'm kind of pushing this down, as you see here, 18 millimeters down, kind of in this direction. And then once I have that, then I'm ready to solve. So to solve in here, then it's important to talk about all the different things that we can solve. So in my case, it's a nonlinear implicit analysis that I'm doing. It's not a dynamic analysis. I don't need a full dynamic in here because I'm not looking at the inertia effects, but it's a quasi-static, and I'm actually using an implicit solver to do that. But there is a lot of different type of simulation analysis or type of analysis that I can create and run. And you will be familiar with some of these as part of Simulation Premium, if that's what you're using. The important here is that we have a different type of solver, this explicit dynamics. And that different type of solver helps me create and run very computational heavy applications. So for example, in here, then before I talk about solving in the cloud, I want to talk about that type of solver. So we have an implicit solver and an explicit solver. When I'm looking at a implicit solver, to solve anything, I have to calculate the stiffness of my entire structure to be able to solve it. And then I solve everything concurrently. Depending on the number of degrees of freedoms that I have, it looks something like this. It kind of scales up very quickly. So the more degrees of freedoms that I have, the more this is kind of computational effort, or I'm going to call it just the time to solve, is going to take time or more time. What happens with the explicit solver is that it doesn't solve the entire structure. It uses the wave propagation method to be able to do that. So if this is kind of the implicit solver, then we also have kind of an explicit solver. And this uses, like I was saying, this uses the wave propagation method, which means that it just solves in the area of disturbance. And then it calculates how that disturbance is propagated through the model, and then it solves kind of one step ahead of that. The advantage of these is that for kind of a lot of degrees of freedoms or very a lot of iterations, so a lot of quick times, so impact loads, then it becomes a lot more efficient that implicit solver. So we're going to have a full webinar to talk about these implicit and explicit solvers and kind of the background between them and what we can do with each of them. But it's important to highlight that this is one of the main difference between this type of simulation tool and other simulation tools. They are very high-end explicit solver that Abaqus is known for, the Abaqus explicit. And then because we're connected to the cloud, we have the ability to run these simulations in the cloud or run these simulations locally. So if I want to offload that, then I can offload these in the cloud. I can use up to 32 cores and have a kind of a cloud computational resources solve that, but I could also solve that locally as well. So for example, in here, let me show you that. I have a simulation set up in here, and I wanna kind of create this. Let me just go to my simulation scenario. And then if I click on simulate, then you see that it gives me kind of that option, right? That I can do either a cloud simulation or a local simulation. So if I'm doing a local simulation, I will be able to kind of select up to kind of 4 cores that I have access to, or I could do, if I do kind of in the cloud and I use kind of my credits, then I will be able to kind of create and use more cores, right? And like I said, in here I have kind of impose a limit, the administration imposed a limit on how many cores, but I have up to 32 cores that I could access in there. And then if I say okay to this, then this is gonna be running in the cloud. But like I said, you can also run it locally. This simulation that I have in here, I have already run. So I already have my results, and then I can show you that. So I'm just loading those in here, and you can see what I have, right? So in this case, again, this is the von Mises plot of the different steps of the simulation. I can, the post-processing of the results, and actually this takes me to kind of my last step of those, that is my results. And in here I can kind of animate, I can create reports out of it, I can do all the post-processing. Again, there is a specific tool, this physical result explorer is a specific tool dedicated to post-process and analyze and create, get my simulations that I want. In terms of kind of what it comes down to, there are different things that are happening all at the same time. So these are a few examples of these type of high-end simulations that we could do. So we could have several non-linearities. We could have a material non-linearity. We could have a geometric non-linearity, and then a contact non-linearity happening at the same time. And these are some of the examples of that. These are good applications where we have several non-linearities and we can solve these using an implicit solver. And then to compound that, we could have several non-linearities, but we have a dynamic problem where we have a lot of degrees of freedom or a very quick response needed. So the time steps that we have to select are very small. And then for that, we have that explicit solver. And then we also have kind of that ability to look at these results. Obviously, we could export results, but we could also have within the platform. So I'm back on my browser. This is kind of the dashboard that I was looking at before. And because I'm doing everything in the kind of in the platform, I have that ability embedded to look at these type of results just kind of within the my information in here, right? So if you see, for example, here, if I put it maybe in my 3D search there, and if I expand that, then I am able to look at these results in the cloud. Oh, I have it open somewhere else. Okay. There you go. And then let's go back in here. So this is kind of my result in that website or a web interface. So just to conclude, I'm getting a little bit longer, just under the 5:02. We have a system that is accessible, that is powerful, and that is connected. That it has the ability to work with your SOLIDWORKS simulation geometry, use SOLIDWORKS as your CAD model. It has the powerful engine that is Abaqus and is connected to the 3D Experience platform, and is able to use what is called HPC, high performance computing in the cloud, to solve this type of simulations. Let's conclude this for now. Let's take a look at any questions that we have. So Jessica, I'm going to pass it over to you. Do you have any questions that have popped up in the?
Great. Yes, thank you so much, Jairo. We do have a couple of questions for you here. Actually, there's been a couple of questions on how the SIMULIAworks products compare to SOLIDWORKS simulation.
Yeah, so the Simulia products, yeah, so let's see, how do I do this? Let me go back to the roles, yeah. Right here. So our simulation, like the SolidWorks simulation product, if we have simulation standard, simulation professional, simulation premium, if you think of it somewhere in here, that would be kind of our standard product. Somewhere kind of in here would be our professional product, simulation professional, and then somewhere kind of in here would be our simulation premium. So we still have a lot of functionality in this role, especially the performance engineer and the mechanics engineer role, that goes beyond what we can do in our SolidWorks simulation products.
Okay, great. There's another question that I think stems off of that one there, Jairo. The question is, do you have any comparison data between SolidWorks Premium and SIMULIAworks, and the test data result in accuracy, time spent, etc.?
Yes. So there is the way all of these FEA softwares work is that you test this against a benchmark, and one of the two main or the two of the most common benchmarks that are available are the NAFEMS, the North American Final Element Method Society benchmark, and then the AFNOR, which is the French version of that. We have data on both. That would compare the results that you get with any FEA tool, in this case, the SIMULIAworks FEA tool, compared to either the empirical testing or the known analytical result. So we do have information on that. It will be kind of specific to different type of simulation, but that is available. And if somebody's interested in that, then that is kind of there are reports associated to those type of benchmarks that we can communicate. In terms of accuracy, between, if we were to compare these to SOLIDWORKS simulation, the accuracy of SOLIDWORKS simulation for the scope of analysis that we're able to do it would be as accurate as this. Is that there are things that we cannot do, and then the time to solve will be faster in the SIMULIAworks, and there are things that you wouldn't be able to do in the SOLIDWORKS simulation plan.
Okay, great. The next question we have here is reliable hyperelastic material data included in the basic Simulia software package?
There is a set of example materials that is included. It comes with about 100 materials in the database. They are there more as a reference and as a guidance. SIMULIAworks and kind of Dassault and kind of Simulia in general, they're not like a kind of material characteristic or material properties development company. So they don't provide a lot of materials. There is as part of the structural mechanics, so the high-end role, there is a material calibration role that lets you, based on test data, you can create that the constant that you need for that material model. So the material calibration app will help you with that. So for example, we can micro partners with a company called GOM for metrology. GOM also has a division for testing. So with our GOM 3D testing cameras, we can take essentially a video of the material deforming, and that video will be able to specify the data, right? The test data of that material, and then with that, within the material calibration app, then you can get your material. So there are tools in there, but it's not a material library company.
Okay, great. And the last question, unless any more come in here, what happens if the internet fails?
What happens if the internet? So if you see here, right, like we are connected to the platform. I'm running this native app that I have been running. It is actually kind of an installed product. It's just connected to the app. So do I need to be connected to the internet to kind of work in this? You are going to want to be connected to the internet, but if the internet connection fails, you can always kind of save under save here. You see that we have kind of the ability. Oh, I click on the general save. In here, you'll see that we have the ability to save locally. So you can save locally. You can still work if the connection drops. But ideally, you want to be connected. And it's not different that kind of our installed PDF system that if you go and you're not connected to the vault, then you don't have kind of that search functionality. You don't have kind of the extra functionality of PDM, but you still can work. So again, let me click on the right button here. We have the local save, and we can do that.
Okay, great. I think that's all questions answered. Thank you everyone very much for those questions. Before we let you go, we do have a question for all of you that we're hoping that you can answer for us quick here. We've got a quick poll up here. As mentioned earlier, this was only the first session in our 3D Experience series. To ensure we're providing information on the topics that most interest our network, all of you, we would love to know which topics you would like to see from us next. Our next session will be taking place on June 10th. So would you prefer to learn a little bit more about the simulation products and their capabilities, a deeper dive into what we covered here today? Would you prefer to learn a little bit more about the SOLIDWORKS connection with the 3D Experience platform? Or would you prefer to take a look at the collaboration capabilities that it offers? So we'll leave that up just for a couple more minutes to let everybody have a chance to answer there. But once again, thank you, Jairo, for a great presentation. And thank you to all of our attendees for spending a little bit of your Wednesday afternoon here with us. We certainly hope you'll join us for our next session on the 3D Experience platform, which will be taking place on June 10th. And we'll include a little bit more information in our email that'll go out to you with today's recording tomorrow. Okay, I think just about everybody has had a chance to answer here. So I think we'll go ahead and wrap up. Thank you very much, everyone. Please stay safe and stay healthy, and we hope to see you all again soon.